Welcome to IT Project Management. This week we're going to first review a couple of concepts from the past 2 weeks, and then we're going to delve straight into project quality management and product quality management. So in the past 2 weeks, we've talked about how to arrange schedule and budget based on how we structure our project, either with a waterfall structure, that was 2 weeks ago, or with any of the agile structures that are available to us at this point. And we've seen that no matter what structure we pick, whether we go straight down the waterfall path as we're seeing here, or whether we are going to use an agile path that basically works with repetition and time in executing or build and test phase, the one holds true, namely that we always have to manage schedule, we always have to manage budget. And what is important is what we will see today when we talk about not just product quality management, but project quality management. Because remember, a project is only as good as its project manager. So this is what is going to be very important this week. A quick review. Life cycles. Well, we have the waterfall life cycle, which typically is being used for smaller projects, and when we have absolute certainty that our scope is really not going to change very much, so we can nail that down at the beginning of the project. And we develop and then we deploy. And if it's a small project, if it's a version upgrade, things like that, not much new functionality going on, then waterfall is perfectly fine to use. If we have a project that is more explorative, if we're developing something completely new, or if we have major redevelopment going on, then an adaptive cycle, either a Scrum cycle with time boxes or a Kanban cycle in which work flows through the through our development cycle on a continuing basis, is probably a better choice. Most organizations, however, opt to combine the two. They opt to combine predictive and adaptive models into a hybrid model, simply because documentation never goes away. The need to track budget and schedule never goes away as much as sometimes we'd like it to. But really the important part. So one of the important things that we discussed regarding agile or adaptive project structures is that we don't work necessarily with specific requirements in terms of, well, we do work with specific requirements. Don't set out these requirements directly as derived from a scope statement as we would do in a waterfall environment, but instead we develop what's called the user stories directly from vision. As we develop a user story, it follows the grammar here as a something want, something so that, and then the reason for it. And then the next thing we develop right after the user story is the test approaches or the test scenarios. So we know that what we're going to test reflects the reason for the user story. And only when we have both the user story and the test scenarios built, then we start coding, because then we code to the test scenarios so that we know exactly what kind of code we need to write to fulfill these scenarios, and so that we know exactly not to write code that does not address the test scenario. As mentioned earlier, we have an option to follow a number of models. 2 of them are Scrum and Kanban. Scrum moves the work through by allocating the items from a product backlog, that's what the product owner does, right, to a sprint backlog. With a sprint backlog, then the team distributes how they're going to work those user stories or those tasks, depending on what the user stories are being broken down to, how they're going to work that off in a sprint that's typically anywhere between 2 and 4 weeks or up to 30 days. And during that period, There's a daily step meeting, 15 minutes, in which each team member answers the 3 Scrum questions or the 3 sprint questions, which are: what did I finish? What am I working on right now? And what um, uh, what. So then sprint continues. At the end of the sprint, we have the big sprint review meeting, at which the team demonstrates the outcome from the sprint to the user. The user gets to play with the finished product at the end of from this sprint. And then, of course, we have the retrospective, at which the user decides whether or not to accept the results from the sprint, and that's always nerve-wracking, but after a while you get used to it. So then we enter the new sprint with another review of the product backlog, and then the product gets to pick the next user stories that we work on, and so on and so on, until either the time is gone, or the money is gone, or the product backlog is gone. Kanban, however, remember, the work doesn't move through in these little time boxes that we see here with the sprint backlog, right? But Kanban, we have schedule set, and then the work from the backlog moves through our development cycle, and we don't have to wait for a sprint to end, for a 30-day period to end. If we're done earlier, well, we pick up another item from our backlog here, right? And means also that at some point it did that without any limits. Then people earlier in the development cycle would be done, maybe, and people later in the development cycle would be crazily working very, very hard in order to get everything completed. This is why we have instituted what is called work in progress limits. Those are the little numbers that you're seeing here. And the work in progress limits determine how many items are allowed in a column. Like, for example, in selected here, we have items D and E. We have 2 items allowed here, so D and E is 2 items, right? In development, we have 3 items allowed. So we have E and C, right? 3 items. And in production, of course, for production, we have no work in progress limit, right? So we can only pick another item from the selected list and put it into development if one of our items from the development list has moved on into production. A moves into production. We have 1 vacancy right here, and we can pick either D or E from the selected list and put into our dev environment, which leaves an open position here in selected because we have a work in progress limit of 2. So we are able to pick the next item on our list in the backlog. That would be item F, right? And that's how the flow goes. And it is regulated in these work in progress limits in order not to cause any bottlenecks or any stoppages. And if we have a situation like this here, where we can't finish something in development, then folks who are waiting here, or folks who are waiting here and have nothing to do will run into development and will help get anything done that needs to be done at this point in order to make sure that the flow stays continuous. All these items are really, really important when we talk about project quality planning. Project quality planning looks really, really simple. We plan quality management, we perform quality assurance, which means we check that our processes are functioning correctly, and then we can control quality of our output. Right? Not so fast. So first of all, in order to plan our quality management, we understand that you cannot manage what you don't measure. And really is the mantra of any quality management. Quality management means we measure our targets, we measure our goals, so that we can compare the quality of our output later on to the measurements and to the targets that we have set up front, right? Measurements should be specific, measurable, attainable, realistic, and time-bound. We all know that. We've had that much earlier in our course when we developed a project charter and we talked about key progress indicators. The whole idea of quality management at the end of the project is that, or in the middle if you're in an agile format, is to make sure the customer signs off on the line that says, yes, I accept the out of your project, whether that is a large installation at the end of the project if you're choosing a big delivery, or whether that is just an incremental delivery at the end of an agile cycle. So now there's a number of quality philosophies and a number of quality principles. The important thing is that we understand quality management runs on data. If we capture data we cannot measure, if we cannot measure our progress, then we can't manage it. Again, you manage what you can't measure and what you don't measure, right? Brain requires investment, it requires money as well, right? So that means we have to talk about how much can we spend on quality management. And how much we spend on quality management is called the cost of quality. The cost of quality is really two parts. On the one side, it's the cost of good quality, which is prevention cost. It is what we invest into our production process to prevent a client. Imagine if, for example, we didn't test our software and we were going to deliver bugs to our customer. Our customer would not be very happy, right? So this good quality cost, or the cost of good quality, this is the investment in not just delivering good software, delivering a good IT product, but it is also an investment in the customer confidence in our products. And the more we invest in the customer confidence in our products, the likely our customers are to stick with our product as well. And that's a good thing, right, in a competitive market. On the other hand, we have here the cost of poor quality. The cost of poor quality is the cost of fixing things. Now, the cost of poor quality is unavoidable. Like fixes, for example, like sometimes warranty repairs on hardware, right? But really, you always want to catch problems before they get to the customer, right? Sometimes that requires rework. Sometimes that also requires delays, waiting time when you have to pay for somebody to wait for something else to be done, right? That, of course, is a cost of poor quality, and that is not the quality of the product. No, that is the quality of your planning, right? Downtime, for example, right? So the cost of poor quality inside our manufacturing cycle, and the internal failure cost typically needs in some way that occurs before the product reaches the customer, right? Now, one cost that is really the hard cost to plan that really should happen is what's called the external failure cost. For example, if you were going to build software that goes on a brake system for an automobile, right? Automobile sensors or ABS sensors, that kind of thing, right? And all of a sudden that software fails or it is buggy and people die. Then their fees will certainly start suing your company. They may even start suing your department, because if they can prove that you were the one who put untested or buggy software on those brake sensors and in return caused the death of people, the company will be liable for so many millions of dollars in damages and that kind of thing. This external failure cost needs to be avoided at all costs. This also means that you really have to understand prevention costs are much more valuable, are much more valuable investment at this point, because you really want to prevent any accidents from happening that will impact the cost of poor quality here. The question is, well, how much do you spend on this cost of good quality, right? So at that point, you're going to have to, and that's what your risk manager will typically do the math and look at, well, what is the cost of good quality, of poor quality, what is the cost of good quality, and where is it likely that these two will break even, and that's what we have right here, right, at this point. And this is where we have just enough. And when you're at the just enough point here, at the break-even point between the cost of poor quality and the cost of good quality, that is when you have optimized your total cost of quality. Right? And it's better to invest in cost of good quality, right? Because poor quality is a risk that you want to prevent with that investment. So the next thing that we need to include in our quality management planning is our do, plan, check, act cycle, which is our Deming cycle, of course, right? And we are doing quality assurance. Quality assurance means that we look at, are we building our how are we building our product? Are we following all the right processes? And are we actually building the right thing, right? And then we also have to check our product in order to ensure that we don't have any bugs in our product, or that our product works correctly, right? So we need to perform some validation that asks the question: did we build the thing correctly, right? So this is what we this is performing the monitoring and control phase. And then for each quality management cycle, really, we need to ensure that we catch and capture anything that went wrong, and also anything that goes well, so we can determine where we need to improve our processes, our project management processes, our production processes, and all those things. And this is where the ACT comes in, really. The ACT here means we need to make sure we continuously improve, right? For all of these thought deliberations, we use a project quality plan to document them. Here is typically the outline of a project quality plan. Here again, a project quality plan determines measurements, because you can manage, but you don't, right? For quality dimensions, project quality plans are typically governed by frameworks and by industry-specific frameworks sometimes. Those can be ISO frameworks, can be Six Sigma. You've probably heard that. It can be total quality management. That's a little bit older here. It can be Baldrige processes. It can also be CMMI, which is the capability maturity model integrated. We'll talk about that in a little bit, right? The idea is, though, that both process quality and product quality, with application of any of these frameworks or derived frameworks, will lead to project success, right? So, and the important thing is, project success means you add measurable organizational value to the organization, right? MOV. So project success does not mean you followed your schedule, you followed your budget, and boom, you got your scope done. If you developed the wrong project, value, right? But it doesn't mean that you shouldn't strive to meet scope, schedule, and budget goals. And we'll look at that in a moment, right? So, and make sure that you track the causes for product rework and waste, and that you eliminate the causes for product rework and waste very quickly, right? Okay. So the idea then of product quality is that your product conforms to the requirements, or to fulfill the user stories in the test scenarios, right? And the product is fit for use. For that, you need to define your approach and your tools, right? You have to perform verification and validation. You want to gather your knowledge so that you can get better at what you're doing. And of course, most importantly, also, you want to ensure that you have good configuration control. So in tools, if we look at the capability maturity model here, this is really one of the most frequently used models in order to ensure quality assurance or to perform quality assurance, and in order to ensure you have a good quality framework going on in your organization, not just for a product, but also for a project, right? The capability maturity model is a stepwise model in 5 levels. It's at level 1, which is called initial. It might as well be called chaos, because level is a completely reactive state. Nothing is planned, nothing documented, nothing is being measured, etc., right? And then moving through these stages, and we're to collect measurements, we're starting to define our processes, right? So the mean here is somewhere around level 2 and level 3, you will most likely have a project management office. If we're talking about project management process quality, right? Your PMO, you will most likely have a project management methodology for the organization in which you work, which is, to be documented in a handbook that each new project manager gets, and that says, here's how we manage projects in our organization. This is great, right? And then level 4 is where we are starting to use the numbers that we collect in level 3. Remember, you can't manage what you measure, right? Or what you don't measure. Where we use the numbers that we collect in level 3 and in level 4 and going forth, right, to evaluate the performance or the goodness of our processes and our products, right? And as we move from level 4 to level 5 to the optimizing, right, that's where continuous improvement really becomes important. This is where we have regular project reviews. This is where we and product reviews, of course, as well. And we review our processes for how effective and how efficient they are. This is also where we make changes to our processes in order to ensure that we, for example, catch more bugs, that we shorten our delivery time or our development time, that we optimize our solution finding processes or our testing processes. Sometimes that can mean that we switch from Scrum, from time boxes to Kanban, things like that. So everything is open for discussion in CMMI. And this, you have here an overview of level 2 and level 3 of level 4 and level 5. As I said before when we discussed the graphic, level 4 and level 5 are metrics driven. So every quality management cycle has to consider verification and validation, right? Validation talks about, did we build the right product? So we look at the requirements and we make sure we didn't go take a juncture within our development that we should not have taken, right? That is always validation. Validation testing asks the questions and pursues the questions of, does the system function as intended? And does the system have everything that we have defined in the project scope? So, of course, we are also looking at verification. Verification is conducting business reviews, management reviews to make sure that we build the product the right way. How do we combine these two? V&V, or verification and validation, are always part of any kind of testing cycle and really throughout the entire project. Because remember, good quality management means catching problems as early in the process as possible, right? Because if we catch later, rework, the more rework we have to do, the more expensive things are going to get. So each project in software specifically, but also in hardware, we'll be looking at least 3, if not 4 levels of testing. Level of testing, unit testing, is typically performed during peer review, and that is within the software development team, either black box testing and white box testing, or most often as gray box testing. And this is developed or is performed within the software team itself. Testing is typically performed in collaboration with the system engineer or the system administrator, because we need to take several different software modules that we have built or that we have upgraded, then connect them and ensure that, for example, we have data flow from one through another into the last item that processes our data, things like that, right? So integration testing leads us into systems testing. In systems testing, we take all our new code and we insert it into the existing code. And part of systems testing is also regression testing, where we check that the old code still works when it connects to the new code, and that the new code does exactly what it's supposed to do within our established environment. So that's our systems testing, right? And we do stress testing there as well, or smoke testing, as some organizations call it. Yeah, we're done with our testing, in which we can fix without any repercussions. Then comes the final and the most important test, which is we're taking what we have built and we put it in front of our user. And let our user either follow a defined test plan, or we let our user loose on our newly built product in order to perform the functions that they need to perform. Remember, the user is an important ingredient in our user story, right? Our user story starts with the grammar of as a user I want to, right? So very, very important. Good. Having said that, we want to make sure also that we understand that in our user acceptance testing, our user performs this alpha code review, right? User acceptance testing is alpha testing still. And once our user acceptance testing has completed and our user has signed off the product saying, yes, it is good enough to go to market, then our product gets deployed, right? Now, how does our product get deployed? Well, our product gets deployed through configuration control, because configuration control itself is our last bulwark between our test system and our live system, right? Our production system. So configuration control changes to our live environment. Let's say, for example, you build new functionality or a new database functionality for Amazon.com, right? You just want to you certainly don't want to deploy that new functionality in the middle of Christmas season when everybody is Christmas presents, right? So we need to ensure we have utmost transparency with the configuration control team and inform of the changes that were made to the system that is in production. Who made this? When were they made? Why were the changes made? Etc. Oh, metrics. Right. Yeah. Then the configuration management team will perform another review and will perform a review of all our test results and the user acceptance test results. Only when the configuration control team is confident that our newly written code or our newly built hardware is not going to break anything that is already in production, then it will be deployed. It means that all these 4 factors together: approaching tools, verification and validation, configuration control, and knowledge management. Yes, knowledge management, because throughout our process, we need to collect data through lessons learned sessions, for example, or in our in an iterative environment. Of course, our sprint retrospective is going to give us very important data that we can use to approach our next sprint more effectively and efficiently, for example, right? And so we can review meeting minutes and all of these so that we can ensure that we use the data that we collect throughout the project in order to make our processes better and more efficient and cheaper, of course, as well. Right. So for that, we need to look at the standards and the mix that we're going to use. Right. We look at the measurable organizational value. What is that we want to reach? You know, what's the target? We've calculated the target in an earlier session with present value, all of those things. We have identified our project scope. We have looked at requirements, and we've looked at user stories and product backlog, right? We have looked at project standards, right? Reliability, usability, performance, response, conformance, right? I mean, we build something, we want to make sure that we are compliant with any existing laws and regulations. Maybe, right? Maintainability, and etc. And from any of these project standards, and many of these really depend on the framework that you're going to employ, whether it's total quality management, Six Sigma, CMMI, or any other regulations that are industry specific. Right? You derive from them your quality metrics for the product, for the process, and for the project. So, process, for example, you would look at defects that are introduced by the processes that are required to create product deliverables, and you want to look at the effectiveness of fixing bugs and discovering bugs, right? Those are some good process metrics. Some good product metrics would be the quality of the deliverables themselves, customer satisfaction metrics as well, right? And the project metrics, and that's what we will focus on next, will be measured in terms of, well, how well has the project been managed, right? So here are some of the metrics that you will always find that will be tracked about the project that you are going to be in charge of or going to be involved in even, right? So we'll be looking at, in terms of process, we'll be looking at defects and the defect backlog, right? And the fixed response time, that kind of thing. For products, we'll look at mean time to failure, for example, right? Project, yeah, we'll be looking at a number of scope change requests or scope changes, because if our scope has not been defined very well at the outset, we'll have a ton of scope change requests, and that can delay our project end date, and it can impact our project cost as well, right? So then overview tasks that should have started, all those things. And believe it or not, any of these measures reflect on your performance as a project manager. So as a project manager, sometimes you may lie awake at night not being able to get any sleep because any of these metrics here may have gone out of whack on your project. Yeah, look at our project, right? So think about the metrics here that you consider useful, and then about any of these questions. Go on, because we talk about what makes you a good project manager and how you can prove that you're a good project manager. So let's say that we have St. John's Hospital. St. John's Hospital needs to upgrade the operating systems on 500 administrator laptops within the next 10 weeks. Our company paid $200,000 upon completion. Yay! Right? So here's go. 500 laptop upgrades in 10 weeks with a $200,000 budget. how that this project has been managed well by a good project manager, or can I tell that the project manager has failed? This is how to calculate the metrics. Here looks pretty simple, right? We're going to upgrade 50 laptops a week over 10 weeks. Then here is our running tally, and here are the dollars that we have planned at the end of the week. We're going to invest $2,000 into the work until at the end here we're coming out with our $20,000. Okay, great. Because a project manager never has just one project going on, they always have 4 or 5 or 10 projects going on. It's not possible to always keep tabs on a project team every single day, right? After 3 weeks, we check in with the project team, and then we're seeing that in the first week, they graded 50 laptops. Yay! In the second week, that number went to 30, and in the third week to 20. At the we spent $2,000 for 50 laptops. In the second week, we spent $2,500 for the next 30 laptops. Oops. Third week, we spent $3,000 for just 20 laptops. Now, start the warning signs, right? So the actual upgrades that are complete at the end of the week here, at the end of the third week, we have 100 laptops completed. Whereas that was our goal, our plan, and here, right? Our plan was to upgrade 100 laptops at the end of the second week, and $2,000 cumulatively, right? And we're at the end of the third week, upgraded our 100 laptops, so we are 50 laptops behind already, and spent $7,500. That's the actual cost. Okay? That our actual cost and our value here that they do, right? So is side-by-side comparison. Here, plan in blue. Here are our actuals in orange, right? So now we need to understand not only wrong, but we need to understand how we can tell how much value we have delivered. Because remember, projects are all about value, right? And if you're a project manager at this point, you're in real trouble, and you need to figure out how bad the trouble is. I'm going to show you how. So we are calculating with percentages. Now this week, at the end of 3, we were supposed to have 150 laptops done first, and we were supposed to be 30% done, right? End of the third week, actually, we've got percent of our work done, right? Percent complete planned and the percent complete actual did 10%. How are we going to get this now? Well, looking at what we call the Cost Performance Index, or the CPI, which is the crucial metric that a project manager's value and a project's value really is being measured on. We're looking at this. We're at the budget allocation here, $20,000, right? Budget at completion, BAC. We are going to multiply that with current actual percentage complete. We're going to get a dollar number here, right? We can compare that dollar number to the value that was delivered with dollar value that was planned. So we got only $4,000 worth of work done at the end of week 3. We're to get $1,000 done. However, for this amount of work, for this amount of work, to get $4 worth of planned work done, we actually paid $7,500. At the end of week 3 was to pay $6,000. Only 50 laptops behind, but we've already spent $1,500 too many. This is what we had planned to spend at the end of the week. The value that we got out of the week here, out of the third or the first 3 weeks, was not the planned $6,000. It was only $4,000 because we may actually complete only 100 laptops in contrast to 150, right? So cost performance then. For the cost performance, we typically track our values in what's called the earned value curve. And that's project manager themselves as an earned value curve, or it is being tracked by the finance department. And we look at the plan. Here we have a very nicely linear plan in blue, right? And that reflects our dollars that are planned at the end of the week. And then we look at the actual dollars that are spent at the end of the week here. And then we look at the value that was delivered. We see that the discrepancy between the orange square and the gray triangle here is pretty dramatic. And we're also seeing that the blue line here really lower than the orange square, which means that we spent more than we had planned, and we earned less value than we had planned. For that, we have metrics that we can capture. One I have already mentioned earlier, which is the cost performance index. Cost performance index is calculated by dividing the earned value by actual cost. It's the earned value that we have calculated for week 3 was $4,000. We divide the actual cost that we paid for this work, $7,500. So our cost performance index is 0.53. That's a real. At this point, a project manager will have to write a report to explain why this is happening. Now, what are we doing in terms of schedule? Remember, we were supposed to complete 150 laptops and completed only 100. So for that, we can calculate our schedule performance index to determine how a project our situation is. Our performance index will tell us how much we are behind. Our schedule performance index is calculated by dividing the earned value, and see, everything is calculated based on the earned value, here $4,000 again, by the planned value. Now, our earned value was the $4,000. Our planned value was the $6,000, right? This is a schedule performance index, or SPI, of 0.67, which means we are 33% behind. Well, we already knew that because, 100, 150, 50, the 50 laptops that I'm missing is 33% of 100 that we got finished. So, in the ideal world, each one of these should be 1, because it means that the earned value is exactly true to the actual cost, meaning that your estimates are right on the mark. For the CPI and the SPI, where the value is equal to the planned value, so that the result is 1, it means that your planned value and your management of the actual work, your progress on the actual work, really coincide. Now, this is explained in a little bit more detail in our videos here. Planning program status with earned value management, part 1 and part 2. I urge you to take a look at that. And please note that SPI and CPI, schedule index and cost performance index, are always reported in a status report. In fact, we report project all the time, and here are the people who are interested in these 2 most important project quality measures: the index, agile performance index. And typical status reports, CPI, SPI, and cost variance are always being tracked. Now, that report is what we will be talking about in a little bit more detail in a later week. However, I really want you to remember the following vocabulary: product quality, process quality, and metrics. Because remember, manage what you don't measure, right? CMMI, because it is the most frequently used project quality and process quality framework. Value, actual cost, planned value. The cost performance index and schedule performance index. Looking at budget at completion and estimates and all of those parts of earned value management in a little bit more detail. But right now, I'm asking you to please complete the .com courses on managing project quality. Here, this course goes into a little bit more detail on project quality. In this course, calculating earned value goes into a lot more deep depth on earned value than I just did. I just gave you a quick explanation. Calculating earned value will take you into more depth on that topic. All right, all the information that I have for today. Are there any questions that we need to answer? Other weekly question, whether the lecture will be online. Yes, it will be online. Any questions? All right. If there are any questions anymore, I look forward to see you next week or after spring break, but in the next session. And in our next session, we will look at more at project risk in terms of IT project quality planning. And we just had the question of whether these quality metrics apply to waterfall or agile project planning, and believe it or not, they do accompany both. In agile project planning, typically these metrics will be calculated, well, they can be calculated at the end of every week. I've seen them calculated at the end of every month, as well or at the end of every sprint. Typically, that is part of the sprint retrospective. Also remember that at the end of each sprint retrospective, we are calculating our velocity as an additional metric. All right, Navina, any other questions? Questions, this lecture will be online, and I look forward to seeing you again in our session on managing project risk in IT project quality planning. Thanks so much. Have a good, happy spring break to all of you. Okay? Bye-bye.